This will be another problem, LeetCode problem that we'll be solving. Let's go. I haven't solved this before, but I have solved some string permutation problems. Okay, so given two strings s1 and s2, return true if s2 contains a permutation of s1 or false otherwise. Okay, in other words, return true if one of s1's permutation is the substring of s2. s1 and s2 both are strings, and we are returning Boolean value. So let's create some tests to understand the problem better. For example, if s1 is a and a, b, c, the simplest possible example, then it's true, because there is a substring here that is a permutation of this string. To be more precise, let's see b, a, b, c. This is also true, because even though b doesn't exist here, but the permutation ab does exist here. But something like ad in ABC, it doesn't exist. So those are the straightforward examples. Now let's do some corner cases. So for example, if we have ABC as the first string and A as the second, it's definitely false. It's not like a corner case, but it's good to think about, because we are not guaranteed that the second string is always longer than the first one. And if the first one is longer, then it can definitely, no permutation of it can be contained in the second string. Okay, so solution. First of all, yeah, I think we can do a brute force solution, which will be like all possible permutations, which is exponential, and then checking if the permutation is inside the string. That will also be a pretty complicated problem. Okay, not a very complicated, just of m, where m is the length of the second string. So yeah, still exponential type. Show brute force. But what's the thing here, right? The thing is that we don't really need to compare the strings. We just need to figure out if the set of characters of one string, of the first one, is a subset of characters of the second one. Because then the first string can be permutated in any way, so that it can fit whatever the substring that we want of S2. Oh, actually, is this the case? A substring. So it depends on how we define substring. So if substring is like the exact sequence of characters, it's one thing. If it's like some combination of characters, it's a different thing. Okay, I need to see AB, B, AB. Oh, okay. So that's not enough. The definition of substring is that it's like a sequence of characters. Okay, so the first idea that comes to mind here is use dictionary, right, and compare two strings. So dictionary of characters, and we create the first one. Let's say that the length of S1 equals n and length of S2 equals m. So in O of n, we are creating the first dict of characters for the first string. It's like counter of characters for the first string. So then we need to find if any substring of S2 contains this dictionary of characters. We actually know the exact length of substring that it should be, because it will be n. So we just need to do a sliding window over the second string and calculate the number of characters in the substring, and then like for each character. And then we will be able to figure out if two dictionaries are the same or different. The only question is, how do we do that quickly? Because we can compare two dictionaries in of n time, but it would be too long to compare those. So we need to figure a better way of comparing the characters. So yeah, okay, I'm saying of n, that's not correct. We will be comparing those in of 1, because we have a very limited amount of characters. I'm assuming that we have just like 26 characters in the alphabet. Whatever is the number of characters in the alphabet, it's a constrained number usually, so we can assume that eventually it will be of the number of characters in the alphabet, so it's the same as of 1. So it's constant time to compare two dictionaries in this scenario, because those are the dictionaries that are counters of characters. So I don't think that we need things more complicated. But if we wanted to compare, like if the number of characters was a changing value, then we could think of some more clever way to compare those, like some hashing, some numbers. Yeah, I don't have an idea right now how to do that, but we don't need, so I will just assume that it's fine. Okay, so let's again focus on the running time. So of n to create a dictionary of characters, then of m to do a sliding window over the second string. So it would be of n plus m, but we will add a specific case for these kind of variables, so that we always ensure that the first string is at least not longer than the second one. And in this case, the second string is always lengthier, so it will be of n of m in the end. Okay, runtime m bigger than n. And we will be spending some space. Of 1 space equals of alphabet size space. Yeah. Okay, that's it. So sliding window. It will be not even some complicated sliding window example, because we will be just moving one character at a time, both on the right border of this sliding window and on the left one. So we will be adding and removing one character at a time. Actually, do we even want to create a dictionary? Yes, I think dictionary will be more readable, because another choice here would be to create a list of length like 26 or whatever is the number of characters in the alphabet, but we will need to be careful with like converting the character into index, and also it's less flexible because we cannot guarantee that our alphabet is just this 26 characters always. It can be bigger or smaller, and then dictionary will work better. Okay, so S1 count will be counter of S1. Then sliding window. Actually, let's add this first clause first, right? So if let's do the same definition. Okay, n is length of S1 and m is length of S2. If m is smaller than n, return false. Wait, it definitely is false if m is shorter than n. Otherwise, we have to actually run this algorithm. Okay, so we have created the counter. I will be doing this. I will be doing for I char in enumerate s2. So for this enumeration, we will be iterating and creating a sliding window. So the sliding window is equal to dictionary, and I'm thinking, how should I be updating this dictionary? Should I make it a default dict? Probably not. Okay, let's do then this. So for I character and enumerate s2, we will be doing window of character will be equal to window character get, sorry, window character get character or 0 otherwise, plus 1. So we are always adding, the indent is like this. We are always adding the character that we are iterating over, but then we need to figure out if we need to remove the character that is length of n behind. So if I minus n is bigger than 0, bigger or equal to 0, then we need to find the character of s2 I minus n. So we are choosing this character, and we do minus or equal 1, and then if this becomes 0, then we just delete this. I'm doing this first for to make everything clear, for clarity. Secondly, because we want to compare two dictionaries, and in both of those there shouldn't be counter of 0, because in this case they will not be the same dictionary. Also, let's assume that you can just compare this window to this counter, even though it's different classes. I don't know how exactly this works in Python, but if it doesn't work, we can also make this a dictionary, just one, so we don't need to worry about that too much. Okay, so I will also need to check that this rule is actually correct, but I think it is. But let's check it right now. So let's say that we are now pointing the I is equal to n. So it means that we have added ith character right now. So the total length of this will be n plus 1, because we are 0 indexing. So yes, we now need to drop the I minus n. Starting at 0, we will be needing to remove one character from the window. So I think this is correct. And now we just need to check if s1 counter is equal to window, return true. There is such a substring. If we have iterated over the whole string 2 and haven't found a corresponding substring, then it's false. So now let's try to do some example. Let me maybe create something a little bit harder. So let's see, say it's C, A. Okay, that's enough, but let's also do C, B, E, A, B, C, A, C. Okay. So this is true. Now let's check how it works. So first of all, yes, we're not returning here false. Here we'll be doing S1 counter is C1 and A1. Now window will be an empty dict. And here we will be adding, so we will be iterating over the string. Let me add a pointer here. So we are first iterating over the string, and let's make our life a little bit easier by 5, 6 by adding the index. So we are getting the value of C, and C is currently 0, so C will become 1. And then here I minus n is actually mentioned, so n is 2. And this 0 minus 2 is not bigger or equal to 0, so we're not getting here, and those two dictionaries are not the same, so we are not returning true yet. We are iterating to the next character. Next character is B. So here we will first of all add it. So B becomes 1. We are still 1 minus 2 is not bigger or equal to 0, so we are not going here. These are still not equal, these two dictionaries. Then we are iterating further, and we are adding E. E equals 1. Okay. And now finally I minus n, I becomes 2, n equals 2, so it's 0, and we start moving. So first of all, we find S2 zeroth, so S2 zeroth is C, and for C we are making it 0, and now we are checking, and window is 0, so we are removing this value from here. And yes, those are still unequal, so we are moving already here. So now it's A will be equal to 1, and we are removing B. So then we will be moving further, and it will be adding B again and removing E. Then we will be moving and adding A, and A will become equal to 2. But then we will subtract 1 again, and it will be 1 again. And then finally, we will be adding C here. So C will be equal to 1, and B will be removed. And finally, those dictionaries are actually the same, because we are not comparing dictionaries. These are not ordered dictionaries. And yes, this looks correct. So let's check. Okay. Yep. Perfect solution. Thank you everyone for watching. Today it was a relatively easy problem. So see you next time tomorrow.